In this video, we're going to review some of our rules for square roots. If you remember going back to doing your perfect squares, a perfect square is a number that is times by itself to make another multiple. So our perfect square list, if we were going to do like 1 squared, 2 squared, 3 squared, 4 squared. So if I had like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. So we can think of that perfect squared list as we go on. Try and fit 100 on there. So that's the numbers 1 through 10 for perfect squares. I really think you should have memorized through 15. So 11 squared is 121, 12 squared, 13 squared, 14 squared, and 15 squared. Those are ones when you see, you should be able to tell me what the square root is right away. Other ones you can punch in your calculator if you're not sure what they are. You wouldn't have to do those by hand. So just to review really quick, number 1 is the square root of 25. You'll notice that I have a negative on the outside, so my negative would be my answer. The square root of 25 is 5. In number 2, I have plus or minus on the outside, so the square root of 49 would be 7, and I keep that plus or minus out there. If you don't see a sign outside of that, when we are dealing with expressions like we are here, you don't put a sign with your number, so it would just be positive if it doesn't have a different sign to tell you how to write it. If you remember sometimes having to put the plus or minus with square roots, that's when you're in an equation. When you're solving an equation, you need the plus or minus. That's required for every problem. But when you are not solving an equation, when you have an expression like we do with these, you just take the principal square root. So you would just list the positive value. Number 3, hopefully you remember, taking the square root of a negative. We can't do that right now. If you punch it into your calculator, it's going to give you non-real answers, what it'll say on your graphing calculator. It might give you an error on another one. But we are not able to take that yet. We actually will be learning this answer, this chapter, so this answer will not always be no real answers. But for now, we would say non-real answer. And by the end of the chapter, we will actually be able to give an answer for this problem. Number 4, just to review how you square root a fraction, you would take the square root of the numerator and the square root of the denominator. So I keep my negative sign that's out in front, and I take the square root of 529. That's not probably one that you know, so you can punch that in your calculator to find it, and you'd get 23. And then you punch in the square root of 2025, another one you probably don't know, and I get 45. So my answer would be negative 23 45ths. And then lastly, we can take the square root of decimals also. I would punch that into my calculator. So I use the plus or minus, and when I punch in the square root of 0.0625, I would get plus or minus 25 hundredths. Hopefully that's a quick get your mind back into the frame of mind of perfect squares. The other thing we're going to review quick is how to simplify square roots that are not perfect squares. This is something you did in advanced or in intermediate algebra and a little bit in geometry. So if you look at number 6, the square root of 98 is not a perfect square. If I punch it in my calculator, I'm going to get a decimal. So what we do for those is we write them in what's called simplified square root form. To do that, we're going to list all of the factors of 98. So 1 and 98, 2 and 49. And I go, does 3 go into there? No. 4, no. 5, no. 6, no. 7, yes, 7 goes in there 14 times. 8, no. 9, no. 10, no. I bet I've hit them all, huh? So here's my factors of 98. What we're looking for is the biggest perfect square in this list of factors. So 49 is the only perfect square I see, besides 1. 1 is going to be part of all your answers, though, and dividing by a 1 isn't going to change anything, so we kind of ignore that 1 is one of our perfect squares. We need something other than 1. So 49 is my perfect square. So to break this down, you always write your circled number first. So I would write the square root of 49 times the square root of 2. The reason I'm picking 2 is because 49 times 2 makes 98. Right now, if I multiplied these two square roots together, I would get back to my original problem. Then, you're always going to be able to take the square root of the first number. The square root of 49 is 7. So I'm going to write that as a 7. And the square root of 2 is in lowest terms. So that's as far as I can go. So it would be 7 root 2 is how we would say that. Hopefully you remember doing that in the last couple years, but if not, this is what we're doing it for, so we get a little more practice. Number 7 then, same idea. I'm going to list my factors of 300. So 1 and 300, 2 and 150, 3 and 100. 4, does 4 go into it? 4 and 75. 5 will go in there 60 times. 6 will go in there 50 times. 7, no. 8, no. 9, no. 10, yes. 10 and 30. I need to keep going, right? 'Cause maybe 15 goes into that. There's a lot of factors here. Do you see how many factors I have here? There is a ton. And that can kind of cause a problem because I'm still not done listing factors. I probably have to check out like 15, 20. Those numbers probably go into 300, right? 25 for sure. So I have more factors to list. The nice thing about this is whenever you hit, if you notice right now, take a look at my numbers. They go from smallest to biggest in this U shape. So if I find a perfect square in this column, it's the biggest one possible, and I have to choose the biggest one. For example, 4 is a perfect square, but I can't choose 4 as my perfect square because it's not the biggest one listed here. 100 is my biggest perfect square listed. And whenever I find one in the right column, I can actually stop listing factors because that's got to be the biggest one because of the way that this flows from least to greatest. So in this column, that's going to be your biggest number. So I wouldn't even have had to list any of these. I could have been done. And from here, then I'd write the square root of 100 times the square root of 3. I'm picking 3 because 3 times 100 makes 300. What is the square root of 100? 10. And the square root of 3 is not a perfect square, so it stays root 3. So my answer there would be 10 root 3. I'm going to have you guys try number 3. If you want to pause it and then check the answer, go ahead and do that. Number 3, hopefully when you listed the factors, you realize that you have 5 times 25. So that's my biggest perfect square. I'd write the square root of 25 times the square root of 5. The square root of 25 is 5, so my answer would be 5 root 5. In number 9, the only difference with these is that I have an actual number on the outside. So I'm still going to break down the square root of 128 the way I always have. I'm just going to take the answer times 2. So 128, my factors are 1 and 128, 2 and 64. Oh, 64. That's a perfect square, right? So I can stop right here. I don't have to list all the other factors. So I would write the square root of 64 times the square root of 2. What is the square root of 64? 8. So I have 2 times 8 root 2. I can multiply unlike terms, so I can go ahead and times this 2 times 8 and get my answer to be 16 root 2. Number 10 then, now we're taking and multiplying 2 square roots together. Sometimes we can end up with really big numbers when we do this, so you might want to break down your square roots before you multiply them. What I mean by that is, I know 3 only has the factors of 1 and 3, so that's as far as I can break that down. But I could probably break down 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. 4 is a perfect square. So I can rewrite 24 as the square root of 4 times the square root of 6, which would make this 2 root 6. Now when I multiply the numbers together, what I do is I multiply the outside numbers, and there's nothing out here, so this is really a 1 out here. So I'm going to take this 1 times 2 and get 2, and then 3 times 6 and get 18. Just like in scientific notation, when we multiply numbers in scientific notation, sometimes in the multiplication or division, your number jumps out of scientific notation. What's happened here is we were in simplest form, but because we multiply these two numbers together, I can still reduce it. Think of when you're multiplying fractions. You might have 2 fractions that are in simplest form, and when you multiply them, they still need to be reduced again. Same idea here. We need to reduce this square root. So I'm going to list the factors of 18, and maybe it doesn't reduce, but I need to check to see if it does. Oh, I didn't have to keep going. Look at that. There's a 9. So I'd have root 9 times root 2. Remember, you always write the circled number first, because that's the perfect square. So I could replace the square root of 18 with 3 root 2. So I'd write this as 2 times 3 root 2, which gives me 6 root 2. The last one, I want you guys to try to break that one down as far as you can go, and then you can check my work with it. So for number 11, I'm going to rewrite the square root of 8. Hopefully you found the factors 4 and 2. So I'd get 5 times 2 root 2, which is 10 root 2. Then 48, this one a lot of students make the mistake of picking a 4 is the biggest perfect square, when in fact 16 goes into 48. So I'd have root 16 root 3, so 4 times square root of 16 is 4, so 4 times 4 root 3. Then when I multiply these I get 16 root 3. So now I need to multiply these two numbers together. So I take the 10 times the 16, get 160, the 2 times the 3, and I get the square root of 6. Just like in my last problem, sometimes when I multiply my number jumps out of simplest form. So I'm going to check my factors of 6 and see if there's a perfect square in there. There's not, so I did stay in simplest form, and that's my answer. Hopefully that is a good review for you on breaking down square roots. If not, just let me know when you come to class.